Let's start with one of the simplest. In this project, I've drawn a face, and there are three what Scratch call costumes: a straight face, a happy smile, and a sad, crying frown. And the aim is to get the face to react to messages that you type to it, smiling if you compliment it, and crying if you insult it. And instead of trying to predict every possible message and put that in the code like I've got here, the kids train a machine learning model so that it's able to recognize whether a new, not seen before message is probably a compliment or an insult. So I'm going to create a new project and I'll call it Happy Face. And I'll tell it that I want to train a machine learning model to recognize text. To train my model, I need to collect examples of compliments and examples of insults, so that the computer can use these to learn to recognize them. So I'm going to create two buckets for my training data, a bucket for compliments, for kind messages, and a bucket for insults, for mean messages. And I need to write examples of each. So I'm going to start by writing 10 of both. I've run this project with groups of kids several times, and it's fascinating to watch how they seem to struggle to come up with more than a few compliments, but they have no problem at all coming up with dozens of insults. It doesn't take long to come up with enough to get started though, and with a few minutes work I've got my first 10 examples of each. So with them I can go into the Learn and Test page. This page gives feedback on that training that I've done so far, but I'm just going to go ahead and start training using the examples I've written. Now this training takes a minute or two, but once it's ready, I can start testing the model. I can test the computer to see how good it is at recognizing new messages by trying it out with new examples of compliments or insults, examples that I didn't include in the training, so these are examples that it hasn't seen before. And if it's not very good, I can go back to the training page and add more examples. But for now, I'm going to go back to my face character in Scratch. As I said before, Scratch is a visual drag and drop tool for teaching coding. Programming constructs are represented as blocks that snap together, and you arrange them on a canvas to make your program. So Machine Learning for Kids builds on that by representing the machine learning model that I've just trained as another block. A block that will snap together with all of the coding constructs that the kids are already used to. This means it's really easy for me to modify that script I had before to make it use the machine learning model that I've created. It'll use the model to recognize the text, and if the model classifies it as kind, the face should smile, otherwise the face cries. By extending a coding environment that kids are already familiar with, I'm not only making the tool easier for them to learn, I'm also sending an important message. I'm telling them that machine learning isn't about replacing coding. I'm not saying they don't need to learn to code because of machine learning. It's about adding machine learning to their toolbox. It's about extending and enhancing what they're able to create with code using new additional tools. So this project is just a fun, quick intro to sentiment analysis as one use for machine learning. Let's look at another project. In this one, students create devices in a virtual room. So here I've got a fan and a lamp. In this project, we talk about digital assistants and how digital assistants like Siri or Alexa can understand what you mean to be able to control smart devices in the home. So I'm going to create another project, and again I want to train this one to learn to recognize text. This time I need 4 buckets of examples for my training data. One for fan on, another for fan off, one for lamp on, and another for lamp off. These are the 4 types of message that I want to train my smart assistant to be able to recognize. And again, the kids just need to write some examples of each of these. And many of the kids that I've seen do this project give more than just the obvious examples like please turn on the fan or can you switch the fan on. They'll add examples like I'm too hot or it's hot in here. Or they'll add examples like it's too dark, I can't see, as an example to train the model to turn on the lamp. The key thing is that it's not about the final result, but about the journey that the kids get to go on. For example, I often see that the first model they train isn't very good at recognizing commands. And then they go back and they add more examples and they see how the next model they train is improved as a result, how much better it is at recognizing commands. This iterative process, seeing the impact of additional training for themselves, this is the sort of thing that helps them to start to understand how this stuff works and how it behaves. I've written a dozen examples for each bucket now, so that's enough for me to get started. Again, I go back to the Learn and Test page for feedback on my training, and more importantly, to be able to train a new machine learning model with just one click. And once this has finished training, I can go back to my virtual devices in Scratch. The documentation here explains that the palette of blocks in Scratch has again automatically been updated, with new blocks to represent the machine learning model that I've just created, and new blocks to represent the labels for each of those 4 buckets of training data that I set up. And I can use these to easily make my digital assistant. Just by dragging a few blocks and snapping them together on the canvas, they're able to see the virtual devices respond to commands in natural language, in English, using a machine learning model that they trained themselves and that they got to see improved as they trained it. With all of these projects, I get the kids to experiment and to test. For example, what if they ask something that isn't anything to do with the lamp or the fan? If I ask this to make me a cheese sandwich, it's disappointing to see the lamp turn off. But if I go back to the Learn and Test page briefly, I can see that the machine learning model actually had a very low level of confidence that it recognized the command from the training that I'd given it. This lets me introduce the idea of confidence scores, of thresholds. More generally, it lets me talk with the kids about why the system wasn't able to recognize this message, because there was nothing like it in the training that it had been given. And learning this lets them update their Scratch projects. For example, in this case, because the confidence score, that number for how confident the machine learning model was that it had correctly recognized the command, because that confidence score is also available as a block in Scratch, I can use this to update my script so that if the confidence isn't high enough, the digital assistant can say that it doesn't understand. Not all the projects that I've been doing with the school groups have been using text. Rock, Paper, Scissors is a good example of a project that uses pictures. In this, I get the kids to create the game Rock, Paper, Scissors in Scratch, using a webcam to take a photo of their hand to let them have their move, and using machine learning to train the computer to be able to recognize what shape their hand is making. So for this, I needed to create 3 buckets for examples of pictures of each hand shape, and I used my computer webcam to take about 10 photos of my hand in a rock shape, in a paper shape, and in a scissors shape. Once I've trained a model, I can go to Scratch, and again my new image classifier shows up as a block in the Scratch palette. The script to be able to use it is super simple, and I just need to add a little script around it to add the rules of the rock, paper, scissors game, and that's enough to quickly get the basics working in Scratch. I've run this activity with school groups a load of times, and what it nearly always ends up highlighting is the importance of variety in the training data. There's almost always at least one kid who tries to rush collecting the training data, who just goes for quantity and takes dozens of almost identical pictures of each hand shape. And their model tends to be very, very poor at recognizing the hand shapes in the game. But then you get them to try again, this time taking a variety of photos with their hands in different positions and at different angles. And the improvement that has in how good their model is at recognizing the photos is huge. As I said before, the final result isn't as important as the journey that they get to go through and the lessons that they learn about this kind of technology as a result. To test the game, I'm going to need another photo of my hand, so again, I'll use the webcam to take a live photo. And the script I want to write is to let the computer make its choice and to be able to tell which of us has won based on its ability to recognize what shape my hand is making. An ability that it has because I trained it to be able to do that. And for kids to be able to see for themselves how this works and how it can be done has a bigger impact than I think you'd get from just telling them about the tech. To make sure it's working, I'll do one more quick test to see if it recognizes that I'm making the scissors sign. So I'll click go. And sure enough, I win. This is another project to recognize pictures, and it's based on the phrase judging a book by its cover. The idea of the project is to get kids to see if they can train a machine learning model to recognize what genre a book probably is, based on just what the cover looks like. For this one, I'm going to choose a few genres: sci-fi, political thrillers, children's books, and romance. The easiest way to get training data for this project is using a website for a library or a bookstore that has pictures of book covers. I'm going to use Amazon, and from there I can easily drag the examples I want into my training buckets. As I said before, when I'm running these projects with the kids, I encourage them to do this iteratively. So they'll do a little training and then see how good the model is, do a bit more training and see the impact that has. In the interest of time for now, I'm going to collect about 20 examples of covers for each of these genres. I've been using the project worksheets as suggestions and as jumping off points. For example, with this one, it doesn't have to be book covers. You could use movie posters from IMDb and train a machine learning model to recognize the genre of a movie from its poster. And it doesn't have to be genres. You could do the year that it came out, training the computer to recognize the differences between movie posters from the 1960s versus movies from today, or to recognize different art styles or works from different artists. The important thing is the tool lets the kids play, it lets them be creative, it lets them try out their own ideas. So none of these projects are intended to be prescriptive. But for now, I'm going to stick with training a machine learning model to recognize the genre of a book from its cover. So now I've collected about 20 examples of each. I can go back to the Learn and Test page to train a new machine learning model. And once that model has been trained, I can create a game in Scratch to be able to test this. I've collected a test set of images, a set of pictures of book covers that I didn't use to train the machine learning model. And I can use this test set of pictures to see how good my machine learning model is at recognizing book covers. And I know that it's a fairer test that way because I haven't shown these to the machine learning computer before. That idea of a test set is another important idea in machine learning that projects like this help to teach. I'm using these test pictures to make a game in Scratch. The game will go through my test set and display one book cover picture at a time. And it will ask both the machine learning model and a person to try to predict the genre based on the picture of the cover. I'm making a game in Scratch to let a person compete against the computer to see whether the computer can be as good at learning to recognize a book by its cover as the person can. The buttons on the left are for my friend to play the game and record their guess, and the machine learning model's prediction is displayed in the box on the right. The script to be able to do all of this is really simple and is again just snapping together a few blocks on the canvas in this Scratch tool that all of the school groups I've worked with have already been very familiar with. Finally, I want to quickly touch on a few practicalities. This tool was created for use in the classroom, which brought with it a few unique requirements. Firstly, it's entirely web-based. There's nothing to install to be able to use it. Children don't need to have an email address to be able to use it. User management is all handled by their teacher, or for coding groups like a code club, by their group leader. The teacher or group leader can create and monitor user accounts for their students and reset passwords if needed. In fact, the tool doesn't need any personal information about the students who are using it. The teacher is free to create anonymous accounts for their students with usernames like Student1 if they want. As well as user management, the teacher section of the tool also lets them monitor the resource limits that are set for each class so they can keep track of what they're using. And as I mentioned before, teachers are also able to download a variety of activity worksheets and template projects, each written to illustrate different uses and aspects of machine learning. So that is Machine Learning for Kids, a tool to help kids learn about machine learning through first-hand experiences, a creative space for school children to make things using machine learning tech, a tool that lets them train machine learning models for themselves and provides them with a guided, visual, creative environment for building and making things with it.